Alright, welcome back everybody. In this video we're going to look at ways that we can use linear functions in various forms and just kind of answer some questions related to linear functions. And here we go. Let's look at this first example. We're asked which one of the following tables can be represented by a line. Now the one thing we should know about lines and linear functions is that in order to form a line, since we're looking at tables here, in order to form a line, the amount that y changes needs to be uniform as x changes by a particular amount. So let's look at these tables and see what's going on in the various tables. In the first table, the x value changes by 1 as we move from one step to the next. And if we look at the y values, first one changes by 5, where the second one changes by 10. So that table does not represent a line. We do the same thing in our second table. Again, I'm checking the x values change by a uniform value of 1 as we move from one to the next. And the y values, let's see, the first one it decreases by 12, and then it decreases by 6. So that's not a uniform rate of change, so that's not going to be represented by a line. Do the same thing in part C. The x values increase by 1s, the y values decrease by 3, decrease by 3. So it looks like this one's our winner as the function that can be represented by a line. Just to double check my reasoning, I'll look at part D. The x values increase by 1s, the y values do not increase by a uniform value from one step to the next. So my choice here is C. This table is the one of all these choices that produces a line. Alright. On to example 2. We're looking at a graph. We have a graph of the equation y equals 1/3 x minus 5. The first thing we're supposed to do is determine the value of y for the point 6, y. And so I'm looking at this, and we're looking for the point with x coordinate of 6. And so we're going to count over 1, 2, 3, 4, 5, 6, and go down to where the graph is when the x value is 6. And that's that point right there. And then we need to identify the y coordinate, and the value of y that fits into this point for this equation is -3. All right. And let's look at part B, determine the value of x for the point x, -6. So now we're looking for where the y value is -6. So I'm going to go ahead and count down 1, 2, 3, 4, 5, 6 to -6. Right here is where the y value is -6. And the x value there is, how about that? It's -3. Alright, so anytime we're trying to determine a coordinate of a point when we're given an equation and a graph, it's really easy to just go ahead and count over and find the appropriate coordinate for that point. Alright, on to the last example here. Here we're given a function. Suppose f of x equals 3x plus 4, and we're supposed to find various characteristics of it. Sorry about that, my phone rang, so I got lost a little bit there. But I'm back now. Suppose we're looking at this function f of x equals 3x plus 4. It's in function notation, and when we want to find f of 3, what that means is in order to find f of 3, I'm just replacing the x that appears here with a 3, and that means replace the x everywhere in the function with that same value. So in order to find the value of f of 3, I'm just going to put 3 in here for x and go ahead and calculate, and the value of that is going to be 13. I'm going to do the same thing here to find f of -2. I'm going to put -2 in here, which means I'm going to put -2 in for x. and go ahead and calculate. And there's the value of f of -2. The last part here, we kind of flip it on its ear. We're told that we want to find x so that f of x is equal to 22. And so when we take this function, instead of replacing x everywhere in the function, like we did in the first two examples, what we're going to do is we're replacing f of x with 22. And so I'm going to put 22 in here in place of f of x and set that up. And now I just need to solve this for x, so I'm going to subtract 4 from both sides, divide both sides by 3, and I find out that x is 6 when f of x is 22. Alright, that's the end of this video. We saw a few different ways that we could apply linear functions in various different forms, tables, graphs, equations, and different ways that we can use linear functions. We'll see you next time. Hope you guys have a great day.